Good morning, ladies and gentlemen. Warm-up says these bugs are not drawn to scale. What does that mean? Stop the video and talk amongst your peeps, deciding what it means. That means that these bugs, as you see them, they might not look like they really look. For example, let me see if I can get this. No, that's not what I want. No. Anyway, like this bug could be the smallest, and this bug could be the largest. Kind of like in your rear view mirror on the car, objects are not as large as they appear in the mirror, that kind of thing. So, is it possible that the bug on the extreme left in real life is the smallest? Well, yes, because they aren't drawn to proportion, so this monstrous thing really could be kind of small. And this fly, it could be a horsefly. It could be this big. It could eat that bad old boy right up. So, we don't know. Next, I like this story. It said, what do surveyors, maps, architects, engineers, and builders all have in common? All of these people use scale drawings. Scale drawings, aka highlight this. Scale drawings are representations of real-life objects that are proportional to the real objects or places they represent. The scale in the scale drawing is given as a ratio. Maps and blueprints are examples of scale drawings. Now would be an excellent time to pause, highlight this definition. When everybody in your group has highlighted it, come back. I'll be here. Hi, ladies and gentlemen. We're on 11:3. Not exactly sure of the page. See if it'll tell me. I don't see the. Okay, next. The person. I know you all can read, but we're on problem 1 in 11:3. Pause it if you need to find your place. The purpose of a scale drawing is to represent either a very large or a very small object. And we have kind of talked about this in the fact that are we talking about the solar system, which would be a very large object, or are we talking about an atom, which would be a very small object? Usually, not every single time, but usually we have the model over the actual, which would be the drawing length over the actual length. Which means, this scale means that for every 1 centimeter on a picture, in the real world, it's 4 feet. So 1 itty-bitty teeny tiny centimeter is 4 feet in the real world. The scale of a map might look like this. So if we have an inch on a map distance, it's 200 miles in the actual distance. So I went to visit my mom, Grandma Diane, so on the map it might look like an inch that I've driven, but really I've gone 200 miles over the river and through the woods to see Grandma Diane. 564. Okay, ladies and gentlemen, now we're on page 565. It says, write a sentence to describe the meaning of each. So, if we have the scale on a map is 1 inch to 2 feet. That means on the map we have 1 inch. 2 feet is in the real world. So we have 1 inch on the drawing or map, 2 inches in the 2 feet in the real world. 1 inch on the map, 2 feet on the real world. Pause and write that sentence. Don't forget to capitalize, don't forget to punctuate. Okay, excellent. It says, on a scale drawing, 1 centimeter to 4 centimeters, which means on the drawing, we have 1 centimeter. Oh, this is terrible. I'll stop. In the real world, we have 4 centimeters. So maybe you made a model of the room you want in your ideal world, and it's 1 centimeter. But in your real room, it's going to be 4 centimeters. So it's 1 centimeter in your room, 4 centimeters in the real world. Pause. Write it down in a sentence. Punctuation, capital letters. Make Mr. T proud. Okay, next one. On a scale drawing, 2 inches equals 1 inch. So because on our drawing it's bigger than in the real world, we're basically scaling down, like maybe with the solar system. So on a scale drawing, where the scale model is 2 inches to 1 inch, that means for every 2 inches on the scale drawing, it's 1 inch in the real world. 2 inches on the model equals 1 inch in the real world. Here we are scaling down. Pause. Write it in your notes. I'm coming back. Okay, our last one is 1 centimeter. On a scale drawing, 1 centimeter equals 1 centimeter, which means that the model and actual equal the exact same thing. The model and the actual equal the exact same thing. Pause, write this down, and when you come back, I'll be on the next page. Okay, welcome back. Here I am on page 571. Wrote it up here for you so you could see. We are on question number 3. It says the scale drawing is 6 centimeters to 1 millimeter. Is the scale drawing larger or smaller than the actual drawing or the actual object? Explain your thinking. So, is the scale drawing of 6 centimeters to 1 millimeter larger? Well, I know you all remember that King Henry died Monday drinking chocolate milk. Let's make him drinking a little larger. Centimeter to millimeter. So here we have 6 centimeters. So 6 to millimeters. We're going from centimeters to millimeters. Zoop! Zoop! You know what zoop is? Moving the decimal. Zoop! Here we go. We have our eggs in the basket. Put a 0. So 6 centimeters to 1 millimeter. If I'm going to change 6 centimeters to millimeters, it means that 6 centimeters is equal to 60 millimeters. So 60 millimeters equals 1 millimeter. Is the scale drawing larger or smaller than the actual? Well, is 60 larger than 1? Yes, 60 is larger than 1, greater than, the alligator can eat that. So 60 is larger than 1, so that means that the scale drawing is larger than the actual drawing. The next one says, given a scale of 5 to 4, explain how you can tell whether the drawing is bigger or smaller than the actual object. Sorry, I'm yawning. And this dude with the scrunch pants says, so since scales are ratios, you can write them in a fraction form like any other ratio. Thank goodness, because I know you guys love fractions. So, 5 to 4. Is the drawing going to be larger or smaller? When we have 5 to 4, usually we have the model over the actual. So, which is bigger, the model or the actual? The model. So when your scale is 5 to 4, ooh, there's this really cool thing. Let's try it. The model is 5 and the actual is 4. So the model is larger than the actual. Okay, folks, now I am on page 573, question number 11. Kind of hopping around, probably come back. But it says, how do you determine if this scale, if a statue is 60 feet high, the statue is 60 feet high, and the scale drawing is 1 foot? Well, you remember in the just previous question, I said it's normally model on top, actual on bottom. So it's model to actual. So if we have our model or scale drawing as 1 foot high, that means we have 1 over the real deal of 60. I'll bet you it's a statue of Mr. Schwann's. 60. How do you determine it? Well, we put the model on top, the real deal on the bottom. So our scale is 1 to 60. Next one, question number 12. Explain how to calculate the actual distance between two cities if you know the distance between them on the map and the scale on the map. Next says, explain how to calculate the actual distance between two cities if you know the distance between them on the map and the scale of them. So, let's say that the scale of the map is 1/2 inch equals 4 miles. And then you're on the road and you break out your ruler to carry with you, and you see that to get from Kansas City to a starting place you're going to is Nowhere, Montana, making that up, and we'll say that it is 5 inches on the map. How far is that in the real world? Look at that, set up a proportion. How do we solve it? Well, we multiply 5 times 4, and that equals 1/2 times x. 5 times 4 is 20, equals 1/2 x. So, how do we solve for x? Well, we divide by 1/2. Yes, for those of you who like it, it is 0.5. And when we take 1/2 divided by, when we take 20 and we divide it by 1/2, we get, tell me. That's right, I'm going to go over here. Take 20 divided by 1/2 means multiplied by 2 over 1, which means 40, and miles. So 5 inches equals 40 miles. Let's go down here and just do another one. We aren't going to do this next one because I know you guys want to do that, but what is? So let's pretend you're going over the river and through the woods to grandmother's house again. And let's say that 2 centimeters on your map, that's an M, is equal to 50 miles on the real deal. And let's say that you have to travel, we'll make our math easy, 700 miles to see Graham. How far must you travel? We'll do T because we know you got to travel. And cross multiply. You can scale up or scale down, but like you've heard me say a million times, I personally like to cross multiply because it's kind of easy. So 2 times 7 is 14. Add my zeros, 1400 equals, when I take 50 times t, I get 50 t. This equation, woo, thank goodness we solved those already. Divide by 50, divide by 50, cancel, t equals, did you do it yet? 28, which means that when I travel, 700 miles, oops, I gotta do that, 700 miles, equals 28 centimeters on my map. Hi, Grandma. So go ahead and try your homework. Sorry for the roughness. I did go visit my mom. Please be good for the sub. The homework is due tomorrow, regardless of what the sub says. Thanks, guys.